Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we're joined by a very special guest from Gaia Converter, and without further ado, please introduce to the audience who you are.
Hello, Mitchell. I'm Christian Jonglas, the head of the technical support team, customer team in Gaia Converter.
Fantastic. Now, just before we dive into this podcast to talk about the solutions you guys provide, just for the sake of the audience, very quickly tell them exactly what it is you like to do in your free time.
In my free time, so I used to ride a bicycle, but it's a little bit over now. In Gaia Converter, I'm doing only analog electronic. My free time, sometimes I do also digital electronic, which is funny.
Which makes two engineers in this podcast, because I too like to do electronics in my free time, and it's hard to get away from it.
I like to play with STM32 or ESP32 just because in my job I don't choose those kind of digital points.
Do you know, I have to quickly say that I'm so happy you said the ESP32, because me and my friend a few days ago, we were actually talking about what we thought was the greatest microcontroller ever invented. And honestly, I think the ESP32, like nobody has done what the ESP32 has done. It's a low cost, really cheap, nice to use, Wi-Fi SoC. It's absolutely perfect, and I love it so much. And I'm just so happy to meet someone who feels the same way.
Yes, even if it is not in the topic of Gaia Converter, but in personal thing, I used to play with that, but I have not enough time. But I would like to get more time on that.
Fantastic. So you're here today to talk about some solutions that your company provides. And as I understand it, you guys are involved in the modular market for power units. Is that correct?
It is correct, absolutely. To build the power supply, you need, if you want to build it, like we say, in discrete component, you need to buy some components separately. You need to qualify those components and build on your board, on your PCB, your own DC-DC converter. Here in Gaia Converter, we propose to change that by a module, which is in a kind of standard form factor, and you can swap out one module, sweep out one module to the other to get your own specification.
Now, modular design is something I personally really love, and I kind of feel like that it's the direction that the industry is going to start going, because it's all the advantages it provides. But would you agree with that statement?
Absolutely, because first of all, it's if you use a COTS module, a DC-DC COTS module, it will be already pre-qualified. If you need to use it or to build it, you need to spend a lot of time on qualification, first of selection of components, and probably your design will loop several times between designing, qualifying, redesigning, qualifying. With our module, you get a kind of assurance that your solution will be already pre-qualified. So you just need to integrate it in your system and then qualify your complete system.
So what markets do the modules that you provide currently address?
So our company is specialized in defense market. Just because we are specialists of defense market, need some special requirement in terms of standard. We need to our power supply need to comply a stringent standard, more complicated than usual consumer applications in terms of input voltage changes. Also in terms of we are using a switching mode power supply. So it means that we need to take care of conducted EMI, the noise, and also radiated EMI. So we are specialized in, and we know perfectly how to cope with those standards.
And so in terms of like the broader applications market, are we talking automotive, industrial, medical, those kind of areas?
Now, we have some part of our application in not automotive for sure, but some industrial application where the requirement is a little bit lower than military standard, but since we are very specialized in military, we will be for sure able to face industrial standard.
Oh, okay. So military and aerospace are two areas that you guys work with.
Yeah, it could be. Yeah, absolutely.
So it's quite interesting that you mentioned that you said no to the automotive, but in terms of like what your devices are capable of working in, defense, aerospace, and military, those are really stringent environments. So these modules must be really high end in terms of their quality.
Yeah. Yeah, absolutely. They are for several reasons. The first one, all our modules are coated in a thermal conductive coating. That means that for vibration, for example, it's an advantage. And the other point is also during the design phase, we take care of the component, the number of components, and also the kind of component we are using to face. I don't know if many people know the MTBF, medium time before failure. The value for defense and military standard are very high. And we are used to design taking into account those figures. And the other point is the thermal operation. So our modules are able to operate up to 105 degree case temperature, which is a very high temperature. For example, in industrial standard, usually the 70 degrees is the maximum operating temperature for any PCD.
So this is a really wide operating range. This is not your typical commercial, quite narrow 0 to 75 width. This is really wide.
Yeah. Yeah, absolutely. And the other point is, in an aircraft, a military or civilian aircraft, nominal voltage is 28 volt.
Yeah.
But you get some surge voltage going up to 80 volt for avionic, civilian avionic, and up to 50 volt. And for ground-borne application, it can go up to 100 volt. So you mean that if you use simply a DC-DC converter, you need to get a wide input range DC-DC converter. This is one point where Gaia Converter is specialized in designing DC-DC converters that can operate from 9 volt up to 80 volt. And this is a little bit specific.
So are you saying that you have modules that will operate from 9 to 80, or is it a case that you have different modules that operate at different ranges?
No, one module. One module. And some times ago, maybe 10 years ago, we were the first on the market to develop a module which is able to operate from 12 volt up to 160 volt. And in terms of designing, it means that we need to maintain a very good efficiency. It's very easy to do an efficient DC-DC converter that will operate at a single input range. You just have to tune it at this input range. Once you increase the input range, the tuning, the design, and some method to get constant or almost constant efficiency over the input range is very complicated. And this is the job that Gaia did since 10 years. And now we got a module which is able to operate from 12 to 160 volt with a very low change in efficiency.
That is unheard of, because most sort of switching power supplies I've seen, when you look at their specs, anything that you start at the low end and you go to the high end, and the efficiency will change over that period. But you're saying that you've managed to make it so that it doesn't really change by that much.
Yeah, absolutely. And it's really difficult to design something like that, but we did it. And another range of application we are also providing product is railway applications. And one point is that this kind of module is able to in rail application, you get some standards of 12 volt, 24 volt, 75 volt, 110 volt, with a surge voltage that can go up to 151 volt. Those modules, just by the DC-DC converter, we were able to sustain all those kind of voltage. It means that with this module, you were able to address several standards. That means that for customers, they do not have to change the DC-DC converter for any application, but one power supply board could be used at several different standards.
And so does that also mean that if you have a design and you've got, let's say, 5 different DC voltages that you need, you could have one type of module, but you'd have 5 modules, but they'd be identical, and then you can essentially tune each one to be the different voltage?
Absolutely. You mean in output voltages?
Yes. So let's say, for example, I've got a single 100 volts coming in from some supply, and I've got 5 different DC voltage buses I need. Let's say 3.3, 5, 9, 12, whatever. You're saying that you could use one specific you could use 5 identical modules, so that each one then is tuned to those different voltages, but you only need that one BOM part.
Exactly. You said it, exactly that. So people were using the name of the DC-DC converter. The series was called MGDD, and it has a double advantage. The first one, that due to the wide input range, you can use in several different applications. Instead of 5 different part number, you get just one part number in your board. But the other advantages is that we develop one product with 2 output channels, which are isolated. So you can place them in series, in parallel. You can connect them in series, in parallel connection.
Oh, that's really cool.
Yeah.
Oh, wow.
Yeah, with the same module, you can do plus two channel of 5 volt, for example, but you can also do one channel of 10 volt. You can also do plus 5 volt minus 5 volt. And you can also trim. We got a trim capability from 10% and minus 20%. So with 5 different output channels, 5 different modules, you can cover almost all the output voltage from 3.3 volt up to 52 volt. And this is also something that helps customer to get just one or reduce the number of part number. It means that our module became more and more universal.
So, because I know from personal experience that if you have to get different power rails and you have to design individual power circuits all the time, but the fact that you said you could put them in parallel as well, so you can increase. Would that also allow for the increase of current if let's say one module wasn't able to provide the current?
Yeah. So for the module I was speaking with 2 output channels, you can parallel themselves easily. So one module with 2 channels can be one module with 1 channel with double power. But recently, we are designing, because our powerful module today is 500 watt. And once we developed this product, most of our customers said it's not enough. Before we got 250 watt, and they said it's not enough, we need more. And we decided to develop a function on this 500 watt module. And this function is in fact just an option, an additional pin to parallel module in a very, very simple way. With just a sensing resistor outside the module, you can place 2 modules in parallel and double the power. So it means that even if our powerful module today is 500 watt, beginning 2025, it is the time when we will develop propose this product, we will be able to propose 1 kilowatt or even 2 kilowatt.
Blimey.
It will be a kind of flexible...
That is a lot of power. So just a quick question about that external current sense resistor. Is that for the sake of balancing to make sure that both modules are equally providing currents?
Yes or not. It's more complex. So in fact, the sensing resistor is just there to measure it's a small resistor, some milliohm. It's there for measuring the current. And in fact, with this measure inside the converter, we will change a little bit the voltage. So the balancing is actively done. And the name of this way of paralleling output is called droop control. So we will droop the voltage over the complete output power range. So we will lose a little bit, let's say 5% of the voltage, but the advantage will be to double the power.
So these modules, I think a really important question is my first question is how large are they? Are we talking inches? Are we talking millimeters? What are we actually looking at in terms of a 500 watt module size?
So, 500 watt, the size of module are a little bit standardized, more or less standardized. So the 500 watt is what we name a half brick. And a half brick is 2 inches by 2 inches, yes, a little bit more. So it's, I can show you, I don't know.
Yeah, go for it.
This is a 500 watt module. This is a half brick module, and this is a quarter brick module. And this is a kind of standard format for our competition also. You can change one by the other. So it's easily to take this module is available at Gaia from one part is one family is 150 watt up to 250 watt. So modularity means that you can select the power and in the same format. And to date, we just have 500 watt in this module, but you can double the power by doubling the number of modules, even easily way. And
to be really clear with this module isn't soldered in; it's pushed into some kind of socket or retainer.
No, you need to solder it.
Oh, you solder? Okay. So it goes onto a board and it's soldered in, yeah.
Yeah, you can see, yeah. And just because you need to solder in a PCB, what we developed at Gaia Converter, this is to help customer to reduce the development or the prototyping. We propose some very simple PCB. It's like some physical footprint where people can directly solder those products and build their own power supply. So I got one here. This is the PCB.
Oh, brilliant.
We give it. It's a very cheap PCB. This is not a PCB for application.
No, just for testing, yeah.
Yeah, for testing. But everything is done. So the customer just have to buy the module, populate the module. You can see here a 500 watt module. Here the transient limiter for able to sustain up to 200 volt. And those two cells of filtering for conducted EMI. And on those, on the seal screen here, you get some QR code giving access to a data sheet of each module, but also giving access to a test report of this board. So with this board, our customer know exactly what to expect in terms of measure. And we did, in terms of test result, we did measurement of EMI because we have capability to measure EMI. We did measurement of efficiency of the complete board, many parts of measurement. So it's a kind of proof of concept, but with result. And this is very helpful for our customers.
So when it comes to using power modules, what would you say is the biggest challenge that engineers face?
The biggest challenge,
yeah.
Knowing the first challenge should be knowing, for most of the engineer are digital engineer, like digital engineer, but they don't know about, many engineers are coming to us saying, okay, I need to comply the MIL STD 1275, I don't know about this, I don't know even the latest. We know all the standards. So the challenge for them is understanding the standard and knowing how to face the standard. And we are here. And it's a big thing. And the other challenge is they need to pass the qualifications. And my team, my technical support team, can help them by doing sometimes some pre-qualification here, or also by helping our customer to support them in how to change a little bit the design to be sure that the qualification will be to increase the chance of success at qualification. So I believe that in military, qualification is one of the biggest challenge.
And if I'm not mistaken, I believe you guys are trying to look into industrial applications for your modules as well. Is that correct? Yes,
but it's in our, let's say that 90% of our activity is in defense, but we have some activities in industrial or highway application where most of our customers trust us just because they think, and it's true, if we are good at defense application, for sure we will be, it will be easy for us an industrial application. For me, industrial application, the standards are easiest to face.
Oh, I can definitely imagine that. I mean, industrial systems are complicated, but nowhere near as stringent as a aerospace application when you've got something flying at goodness knows what speed, and it's got to control something that could be potentially dangerous, and it has to work every single time. So I can imagine that designing or moving from a military application to an industrial application would be actually quite easy by comparison, trying to go the other way. But in terms of industrial applications, the challenges that engineers will face will be different. So what challenges do you think they would face?
Again, it's the same thing.
Exactly the same.
The same thing is knowing the standard. But one point which it's maybe in industrial application, many times you get some part of safety, because if you get any industrial application where a technician can access, you need some double isolations. For example, in military, you don't need double isolation. So this is a kind of this is also the safety standard is a part, real standard, defining some isolation voltages which are highest than in military. In military, the isolation voltage between primary side and secondary side is 1.5 kilovolt. In automotive, I don't know, it should be higher, and in industrial, it should be minimum 2.2 kilovolt plus a double isolation, so that at the first level of failure, you will not be electrolyzed by the equipment. So this is a part of the challenge.
And is this something that your modules can provide at this time?
We got a range of products designed for industrial application with double isolation, absolutely.
Oh, brilliant! And so when can we expect these modules to come onto the market?
They are on the market.
Oh, we're already in the market. Okay, well, there you go. Great, fantastic. All over. Thank you very much. Goodbye. Fantastic. Okay, so how long?
In fact,
go for it.
It is also the modules with a wide input range, because to face different input voltages, and also double isolation and double output voltage to combine output as we want.
Again, and so it's, again, taking the advantages that you guys have made in the field of military, bringing them into the industrial space. So you're saying that the modules have been out already. My question would be to you is, was it industrial engineers who approached you asking for modules, and then you decided to respond to that demand?
Yes. Absolutely, yeah. But in fact, to be honest, probably even if technically we will discuss the design, most of the time our competition in industrial will be there with a lower price. So even if we have some exchanges on technical point, at the end sometimes the price, because our module is not free to get very good efficiency. It's not efficiency. MTBF is not good to be qualified for high temperature, for high vibration. So at the end, people who will come to us for industrial application know that they will pay more for something which is much more better. So that's the reason why our first market is really defense and avionic. And some people are approaching us for industrial application. But let's say that power plant, for example, where you need to get power supply to operate for a long time with a low level of failure, could be an area for us. And we got some application in power plant.
And so what's to pick up on one point that you said, which was about cost, which is quite interesting. Would you say that switching to a modular power supply, or power module in this case, would be could potentially be cost saving for an engineer?
For the engineer, of course. If you ask me to compare what we name a discrete design, and a modular design, like we can offer, for sure it will be a cost saving, even if the module itself seems to be more expensive than a single transformer, a single transistor, and a single capacitor. But at the end, not only the time saving to get the success in application, but also the cost for sure will be low.
And the thing is, I've actually designed a couple of power modules myself, and power circuits, and I know exactly what you mean in terms of cost saving, because the number of times I had to keep redesigning the switch mode was because the RF engineer would come in and say, that's making too much noise, this is not going to work, and the number of revisions we had to go through. If I could have just gone, right, okay, stick one module on there and it's sorted out, all of that time would have just been saved. So it does make sense that by using modules, even though you pay more per piece on the BOM, you actually save money. You save money in terms of development and the fact that you haven't got to spend all that time trying to figure out why it is or isn't working.
Yeah, and this is exactly our latest low power product. You know that the modular architecture is also to place modular filtering for EMI, a module which is for transient limitation. Also, we didn't speak about, but in avionic you need to face interruption, bus interruption. So the way to face that the simple way is to use a big capacitor to charge it, and you save energy during the interruption. But we developed a module which is boosting voltage across capacitor. Since the energy inside the capacitor is proportional to the square of voltage, we can reduce for any given time of operation, you reduce a lot the value of capacitor. So all those modules are separate components. And we just developed, and it is available on the market. The name is PSDG48. We placed all those functions in one single module. I don't get here, but the module is this size, and it's a complete power supply, board-mounted, potted, qualified for military, providing up to 3 channels. So the designer are just to provide input bus, probably an external TVS, transient voltage suppressor, and that's all, and some external capacitor for hold-up. So for people who doesn't know the standards, is really the easier way to power their digital things or RF power system. But for sure, the module itself seems to be very costly, but it includes everything, every function. So if you compare this costly module to the time you will develop your own function, you will compare some, let's say, 2 hours of placing things to 1 year of designing the component. So for sure, it's interesting for people who doesn't want to spend time on power supply.
A quick question, actually, because you mentioned about the because what you're describing is a complete power supply solution. You haven't got to worry about anything. It just sticks something in, and something essentially comes out. But my question is, is it just DC to DC, or is it also AC in and DC out?
Yeah, to date, we are mainly focused on DC to DC. And we have also some AC to DC solutions. So when you are speaking AC to DC, many things are changing compared to industrial application and military. For example, the AC military is usually 115 volt, 400 hertz, while in industrial it should be 220 volt, 60 or 50 hertz, but also the standard are really stringent. So we got some application available on our website, but it's not the main part of our proposal.
And so if somebody was looking to go from AC to DC to provide power to digital circuits, it would make sense to use a transformer with a rectifier and then have that rectified output going into one of your modules, which then continues.
In fact, our AC to DC are PFC, get a PFC function.
Oh, okay. Perfect. There you go.
Yes, inside there is also, sure, you need a rectifying. It is inside, but you need also some control to get the power factor close to 1. It's for 99, let's say.
And that's something that your modules can do.
Absolutely.
Oh, fantastic! And so it's not just the high efficiency that you guys can provide over the entire operating range, but then it's also the power factor correction on the input as well. Yeah.
In fact, we get two family of products. One is able to develop 350 watt, let's say, to build a 300 watt AC to DC solution with a PFC function. So the PFC and THD is in the specification given by the standards. And one other, which is, so this one is, you need to build the solution with 2 modules. One is a high voltage AC to DC, and the other is a down converter isolated. And the other product range we got is directly one module, which is AC to DC with providing isolation inside, and able to provide, we got one model of 35 watt and one of 50 watt with two output channels.
So going back to the sort of 2-inch by 2-inch modules that you were showing earlier, because we're talking, on the topic of efficiency and heat, I'm really curious. Do these things need thermal management, or are they essentially completely self? Does that make sense? They don't need heat sinks and things.
No. So for sure you need a thermal management, but most of application for avionics. So in avionics, it's you almost never use fan. So most of time, or you can place a heat sink.
A passive
on this.
one.
Yeah, a passive. But most of time, the chassis on the application, most of the application military avionics are made with inside an aluminum chassis. So you place directly this module on the complete power system to the chassis, and the chassis is acting like a heat sink. And I mean that most of the time is not a problem. The dissipation is not a problem, even if this module is dissipating 50 watt power. So it's not.
50 watts is not a lot for that size. That's quite a lot.
Yeah.
That's quite a small heat dissipation per.
90% efficiency.
Yeah,
so
that's not bad at all.
90% efficiency. Yeah.
So in terms of the technology, the switch, because these are DC-DC converters at their heart. So what switching technology are we using?
In fact, this is a forward converter. Topology is forward, and we are using hard switching. Just because the reason is that we decided to get fixed switching frequency. For in military, it's very something that customer like, just because if you are acting in a radars application or sometimes video, and if you provide any power supply with modular, or if you modulate the switching frequency just to get a zero switching function, it will be very difficult for a customer to mitigate the noise due to the switching. In our case, the frequency is known, so it's easy for a customer to filter this frequency. That's the reason why all our modules are using low frequency. Let's say low, it's around 300 kilohertz.
And that actually sounds like a really beneficial. That's a massive benefit actually to engineers, because if you know the fixed frequency is what it is very specifically, you can, as you say, you can isolate that very particular frequency with an external pi circuit, whatever it is that you need. Yeah. Whereas other modules can be kind of like dancing all over the place, and so it's kind of like, oh, it's ringing here now, it's ringing there, it's ringing over there, and it's just like you can't really manage it.
Yeah, I got some customers that were got some difficulty with moving frequency. But the other point is that we got a switching frequency synchronization function. Yeah. So that imagine that our harmonic is getting directly in the bandwidth of any video system or any radar or radio system. You can just shift a little bit, so it's not a wide range. Shift a little bit, and so that you can remove it. And we used also we got some applications, some demonstrator using several small modules, 20 watt, 40 watt modules. And in fact, we decided to synchronize each module with an opposite phase, so that the fundamental frequency is reduced. Of course, the two-time frequency harmonic will be a little bit increased, but it's easier to remove by filtering high frequencies and low frequency. Yeah. And this has been very, very efficient. I believe we should have any application note on our website explaining how does it work. And it has been very, very efficient to reduce the noise. So with a very small filter, you can reduce the noise of several modules when they are synchronized in the correct phase.
So again, another example of, even though you've got an external component, because of the way that you guys have designed because you've made them synchronous in terms of their operating frequency, you only need a tiny filter on the output for all of those modules connected.
Yeah, absolutely.
But in terms of, like, when I say technology, in terms of like the actual silicon technology, so are we talking like IGBT? Are they GaN, silicon carbide? What are we looking at in these devices?
So to date, we are using just standard MOSFET, the best one, but the standard MOSFET. Silicon carbide or GaN transistor have been popular by automotive mainly, because automotive is our bus, nominal bus is 28 volt. Automotive is more 400 volt. So those products, or even IGBTs, were more dedicated for high voltage application. This is not to date our domain, but I believe that in the future those transistors are now existing in lower voltage, and we will gain in RDS(on) for MOSFET transistor. I believe that to increase the level of our very good, to date we are almost at 90%, depending on the module, but 91% efficiency. I believe that in the future, if we got some transistor or low voltage transistor with those kind of high bandgap technology like GaN or SiC, I believe we will be able to increase efficiency in a large proportion. But it is the work of the design team today for the product for tomorrow.
But there is an interesting point that you raised. Did you say that your modules work on the lowest frequency side, or is it the higher frequency side, would you say?
Most of our modules are switching, let's say, below 1 megahertz. around 500, 300 kilohertz, 500 kilohertz.
And so when you're operating at those frequencies, like you mentioned, silicon carbide is too high voltage. It's only going to be useful if you've got we're talking 800 volt battery packs where you need that kind of insulation barrier. And GaN makes sense in terms of its ability to switch quickly and its lower voltage operation. But in terms of, but you mentioned something that made me think, and it would suggest that GaN wouldn't be entirely suitable because your voltages are so low, all the way from 9 volts to 100 volts, but that voltage is quite low, that range. Trying to use something like GaN makes no sense because current silicon technology is more than sufficient to give you those high efficiencies.
Yeah, we said 80 volt outside mean that it's 200 volt or 150 volt inside.
Yeah.
Because of resonance and everything. But yes, so let's say that today the MOSFET we are using are more plus minus, let's say 200 volt. And in this range of product, the GaN there are some GaN, but the only advantage we will have is to reduce the RDS tone, and like you said, maybe be able to increase the frequency. But I believe we need to wait some years to get more. I believe that this technology will, over time, replace probably the MOSFET. But let's discuss that 2 or 3 years later. I think we need transistor in our range of voltage.
Now that's very interesting. So when it comes to your modules, as an engineer, what's the biggest challenge that you face when designing your modules? So because as you just mentioned, it's not the switching transistor that gives you the biggest headache. What would you say is the hardest thing to work on these modules?
Let's say the magnetic, all the magnetics, so the transformer and inductors. And in fact, the losses are for those technology separate in a primary side switching, secondary side switching, and magnetics. So there are an area where we can reduce drastically. So we need to take a little bit for each part. In output, most of our products are using output synchronization rectifying, and also, yes, we need to take care of the magnetic. So most of our transformers are, even not most, but all of our transformers are self-made. So it's self-designed. We design our own transformer, even if it is manufactured by the manufacturer. It's a custom one. So maybe if we go back to people who try to design by themselves, let's say an engineer who do not want to use the modular solution but his own transformer, probably he will use a transformer from the market, which is not specific destinated to its application. In our case, we design all our transformer and inductors, and
you design you design the transformer.
Yeah. I'd say we ask.
But you get a very specific transformer manufactured just for your module, and its parameters and its characteristics, and it's been designed for your needs. That's really interesting. So that when you design your modules, you're not trying to look for off-the-shelf components that might or might not work or might give you some range of tolerances. You're like, no, we need a transformer that works like this. We need an inductor that works like that. And because you've got that control over the manufacture of those parts, in terms of what you order and how you get it made, that means that your modules can give you the performance that you guys are giving to your customers.
Absolutely, yeah. And this is a main difference between, if you want to do the same with an existing component on the market,
that's going to be hard.
You will not be able to do that.
All the power to you. If you want to design it yourself, go for it, but good luck, kind of thing.
Exactly. Even for, we are speaking about electrical point of view, but even for a thermal point of view and power density. So in this component, this circuit is an IMS, it's an isolated substrate. Yeah. That means that this is the component are in this side, there are two PCB. One PCB is this one, and the other is a kind of PCB here. So in terms of density of component, is something the designer will not place directly on his board. You never place a mezzanine board on one board. So even on density, he will save space on his board using that. If you ask a designer to build in this surface 500 watt module with 90% efficiency from 9 volt, 16 volt to 80 volt, or 9 volt to 40 volt, I'm sure you will not be able to do.
But basically, this is not something you can just go onto your favorite distributor, find some off-the-shelf parts, stick it together, and assume it's going to work. It's just not going to happen. And so it's taken your company years to develop these solutions and a team of engineers and funding just to get this thing to work. And so, yeah, an engineering team is not going to be able to recreate something like this. But one thing that it does make me wonder, because one thing I always like about modular designs is that they are essentially, because they're modular, pick and place, drop where you need them and put them into a circuit. Do you think that in the future you guys might consider coming up with a solution where modules could be pulled out of a board and then a new one swapped over, so you don't need to solder them permanently to a board?
To date, we do it here, but it's not for a real application. For example, in the board like you see here, we got one board with sockets, and you can plug and play and unplug. But this is just for testing. In fact, due to the power, and you need to get very low resistance, contact resistance. So for this level of power, I believe it's not existing today on even on other market. I think due to the power is a little bit complicated. If one time, and also vibration and everything. So to date, we do not have this. We have some solutions that are not usable in real defense application.
And this is where the crux of the problem comes down, is that because it's defense, you've got the quality requirements and the environment is so harsh and stringent that to have something plugged in that could also be pulled out is probably not going to happen unless you had, you'd have to have clips, you'd have to have multiple redundancy pin connectors that all take the power. You've got 500 watts going through pins. It's not something you really want to have a sort of to make a connection like that. But do you think that's something you might do for the industrial or other markets in the future?
Yes, but for low level of power. I think that today it's a little bit complicated. For 500 watt, let's say that you get 20 amp, so a connection for 20 or 40 amp.
That's a lot of current.
Yeah. So the losses, you need to reduce the losses, and the socket are not the way to reduce the losses.
Fantastic. So just before we wrap up this interview, I've got one more question for you, which is that for the audience who are watching this video, if they want to get involved with your solutions, what would you recommend that they do? So
first of all, they visit our website. Also, in our website, there is a section which is a technical support designs tool, and it's very useful. They can use for, even if they are not using Gaia Converter, there are some kind of calculators for thermal management, so several calculations based on thermal resistances. Even for any other component, you can use that. You can also select all our module. Hold-up solutions are also able to be calculated directly on the website, and they can send us. So if people who see that need, the technical support team in Gaia Converter is very involved and collaborate a lot with our customers. So we can propose some schematic of architecture, we can discuss, we can visit some customer. So do not hesitate to send us a mail at support@gaiaconverter.com, and you will have any answer, and you will have quickly an answer. We used to answer over world with the complete team, because we got some people in Hong Kong, some people in India, some people in US also, and we used to answer any support question in average less than one day. So if you ask any question, averaging, you will have the answer in less than 1 day.
Fantastic.
So it's very
Fantastic. Well, thank you ever so much for taking the time to see us today.